So the next part of our integration topic is going to be integrating using our trig identities. So we're going to relate all the way back to what you did in the trigonometric chapter. So we've got to use double angle formulas. We're going to have to use identities from cos squared plus sine squared equals 1, sec squared. All of those identities that you've had to learn and use, we are going to have to use again. Remember, you've got your formula book to help you. You also need to make sure you've got all of your standard integral functions that you need to know from a couple of lessons ago, and make sure we can use those accurately as well. So if we start with something like integrating sine squared, okay. Now, I don't want to try and integrate something with a power if I don't have to. So what I want to do is I want to change sine squared into a trig function that isn't squared. So I've got to use one of my trig identities to try and eliminate that squared part. Okay. Now that's going to involve using a double angle formula. So we need to think back what double angle formulas will include a sine squared or a cos squared and so on. So the one we're thinking about is going to be cos 2x. Okay, so we know that cos 2x, okay, gives us a multitude of different identities. It's the one where we have 3 to choose from. Now, obviously, I'm aiming for one that's got sine squared in it, so I'm going to go cos 2x, and that's going to be the same as 1 minus 2 sine squared x. Now, if I want to substitute out sine squared, I just want to balance this equation a little bit. So I've got sine squared as the subject. So I'm going to move sine squared across, move cos 2x the other way. So I end up with 2 sine squared x equals 1 minus cos 2x. And then I can get to my sine squared x is going to be half minus half cos 2x. Now, yes, that may not look any nicer, but because these functions are now not in terms of a squared trig function, I can integrate a lot happier. Hopefully, you will recognise something like a half minus a half cos 2x is something we had to integrate last lesson. So, back we come to the question. I'm going to rewrite this now as the integral of a half minus a half cos 2x, again, with respect to x. And I'm going to go through and integrate. So a half is going to integrate to a half x. My half cos 2x, okay, again, we need to think carefully about this. So if I think about what we did last lesson, if I take my half cos 2x, and what I'm going to do is I'm going to just move it over here. So I'm going to rewrite that as a half times by cos 2x, and then I'm going to think about integrating. Okay, obviously my half isn't going to change. So my cos 2x, again, we need to remember our process for integrating with sine and cos. So we go sine, cos, minus sine, minus cos. As we work down, we differentiate. So we work upwards, we integrate. So cos becomes sine. So that's going to become sine 2x. However, when I integrate in the form with a coefficient in x, I have to make sure I include my times by 1 over my coefficient. So in this case, it's the 2. Okay, so it becomes times a half. Therefore, when I combine this part together, I'm going to get a quarter sine 2x. So that is what you practiced last lesson. Hopefully, we aren't in too much trouble with that. Obviously, I've got my negative sign as well. So that's going to be a half x minus a quarter sine 2x. Again, it's indefinite integration. I haven't got limits. You have got to remember your plus c on the end. Okay, so what I'm looking at doing is using my trig identities, okay, to eliminate where I've got problems with integrating so that I can get it into the form of a single trig function that isn't squared, that isn't cubed, okay, that aren't multiplied together so that I can integrate happily. So if we have a look at another one, so this time we've got find the integral of sine 3x cos 3x dx. Now we haven't looked at integrating if we've got a product yet, so I want to try and eliminate that product. Now if I see sine and cos multiplied together with the same variable in there, I should hopefully recognise that quite quickly. Okay, this is a representation of the double angle formula for sine. Okay, because I know that sine 2x equals 2 sine x cos x. So again, it's picking out the trig identity that matches to what we want. Now that's very close to what I'm looking for. I just don't want the 2 in front. So that means I'm actually going to be interested in a half sine 2x. That's going to give me my sine x cos x. The only difference I've got is I want 3x instead. So if I change this to sine 3x cos 3x, rather than being a half sine 2x, it's going to become a half sine 6x. Okay, that means I can come back to my original function. I'm going to rewrite my original integral as the integral of a half sine 6x instead, again with respect to x, and then I can go about integrating it. Again, all I'm looking to do, okay, is integrate from there. So don't forget from our little feature to differentiate between sine and cos. So going down is differentiating, going up is integrating. So if I've got to integrate sine, I come all the way back around and that's going to give me minus cos. Okay, so the half stays where it is. So this is going to become half times by minus cos x. So minus cos 6x. But again, because I'm not integrating just in terms of x, I have to make sure I times by 1 over my coefficient of x. Okay, so I'm going to be left with a sixth times a half is going to give me a 12th. I've got my minus in there as well. So I'll end up with minus a 12th lots of cos 6x. Again, indefinite integration, we have to make sure we put our plus c on as well. Exactly the same idea, guys. If it's not in a form that we like, okay, we need to get rid of it. So we need to use one of our trig identities to manipulate into the form that we want. Last one I'm going to show you, and then, last couple even, and then you're going to have a go. Cos x squared, exactly the same idea as the first one was. Okay, so trig identity with cos squared, well, that's going to be cos 2x again. Okay, but this time I'm going to be looking at using the version of it with cos squared in instead. So cos 2x is going to give me 2 cos squared x minus 1. So when I rearrange it, cos squared x, okay, is going to be minus 1. It's going to be 1 plus cos 2x all over 2. So just going to rewrite that into a slightly nicer form. So I'll have a half plus a half cos 2x. Exactly the same idea as the first example. So we are now left with the integral of a half plus a half cos 2x. Again, with respect to x. Integrate the half to give me a half x. Integrate the half cos 2x. So again, the half is going to stay where it is. The cos 2x, when I integrate, goes to sine 2x. But again, because it's not just x, I have to multiply by 1 over that coefficient of x. So I'll end up with, when I simplify this together, a half x plus a half times a half to give me a quarter, sine 2x. Make sure we do not forget our constant of integration. So this is exactly the same as what you've already done. All we've got to make sure is we think about what trig identity we can use to manipulate into a form which we can integrate happily. Okay, right, last one is slightly different. So not all trig functions that have squared in them we want to try and get rid of. Some of them we can integrate, and this is where you need to link back to your formula book, because sometimes when we integrate some trig functions squared, for example things like sec squared, we can integrate quite quickly and quite happily. Okay, so hopefully with using your standard integrations from before, you can notice that sec squared is one of the trig functions we can integrate happily. I also know that from tan squared, there is an identity that links tan squared and sec squared. So I know that tan squared equals sec squared x minus 1. Therefore, I can just rewrite this original integral of tan squared x into sec squared x minus 1 with respect to x, and I can integrate my way through. Sec squared, using our standard integrals that we need to know, sec squared integrates to tan x minus 1. Please do not forget the integration we did in year 12. Do not miss a simple part. Okay, it's really important. If you've got a half times by or 1 times by a trig function, then that's fine. That's just a coefficient and that won't get involved in the integration. Because this is a take away 1, 1 is its own term, therefore we can integrate it. So integrating minus 1 takes us to minus x. Again, it's indefinite integration. I need to put my plus c in. Really, really careful with these. If you can't integrate it or you don't recognise how to integrate it, can you manipulate it into a form either of a standard integral function or into the form of something that we do know how to integrate easily? Okay, a couple of different things that we need to do. Right, what I want you to do now is pause the video, have a go at those two onto your paper, and then we will go through the answers afterwards. So pause now, please, have a go at those two questions, and we will have a look. Okay, so integral of sec x plus tan x all squared. Now, I definitely don't know what I'm doing with this at the moment, okay, because I've got two functions added together then squared. If you've got brackets at the moment like this, my first thing, if it's not something I recognise quickly, I'm going to expand them out. So let's expand sec x plus tan x all squared out into a singular function. So we will end up with sec squared x plus 2 sec x tan x plus a tan squared x. Okay, right. Now from this, I can start thinking about how I'm going to integrate. Now I'm happy with the sec squared. We saw from the last example I can integrate sec squared x quite happily. 2 sec x tan x, again, that's one of my standard integral functions to integrate that, because that can integrate back to sec. So that I'm happy with that one. Tan squared is the one I'm not so happy about. Don't know how to integrate tan squared straight away. However, as we saw from the last example, I can use a trig identity to change this. So I'm going to keep my sec squared as it is, keep my 2 sec x tan x as it is. They're both parts I am happy to integrate. I know how to use them using standard integral functions. My tan squared x, I'm going to change, as I did in the last example, to a sec squared x take away 1. Again, both of these parts I know how to integrate happily. Now, all I've got to do, because these terms are added together, I can integrate all terms separately. So, integrate of 2 sec squared, because I've now got 2 of them together. So, what we will do first is let's just tidy this up. So, I'll have 2 sec x tan x minus 1. So, 2 sec squared, well, sec squared differentiates to tan, integrates to tan even. The 2 is just a coefficient, so we can leave it as it is. So, we'll have 2 tan x. Sec x tan x integrates to sec. So again, we've just got a coefficient of 2 we leave in front. And finally, my 1, nice and simply, integrates to Rx. Again, do not forget your constant of integration. This is all about making sure we can manipulate the expression we're given into a form that we recognise and we can then integrate. Okay, so second question you should have done. So this time we're integrating with limits. Okay, so we're going to need to do our substitution to find a final answer. Right, we've got sine squared 3x. Similar to the first example we looked at, the only difference is we've now got a 3x in there as well. We're going to follow the same idea. So I know sine squared of 3x. I want to change that into just a singular sine or a singular cos or sec squared or something I know how to integrate happily. Now we saw from the first example that I can change sine squared x into a trig function using my cos double angle formula. So the fact I know that cos 2x is 1 minus 2 sine squared x. So I know that sine squared x equals a half minus a half cos 2x. Okay, it's what we looked at in the first example, but I don't want sine squared x. I want sine squared 3x. That means all we do is we change our way along. It was x to 2x, so it's now going to be 3x to 6x. So all that means is my integral has now changed. So I'm still integrating between pi over 3 and pi over 6, but I am now integrating a half minus a half cos of 6x dx. So we'll go through and integrate each part. It's definite integration now, so I can use my square brackets. So I'm going to end up integrating a half integrates to a half x. My half is going to stay where it is because it's a coefficient. Cos 6x, remember we're going up our little system, is going to become sine 6x. But again, we're integrating with a coefficient of x. So I have to times by 1 over that coefficient as well. That's the extra balancing. That's the manipulation between pi over 3, pi over 6. I do ideally want to just tidy this up a little bit so that I know I'm substituting straight into something. So we're just going to substitute that, simplify that a little bit. So it's going to be minus a 12th sine 6x. But again, still between pi over 3, pi over 6. Now, all I need to do is substitute in and find my answer. So, substituting pi over 3 in gives me pi over 6 minus a 12th lots of sine 2 pi. And again, subtract. I always want to put the second part in brackets. If I'm honest, you can put the first part and second part in brackets because the double negative is going to make a big difference. When we substitute pi over 6 in, we end up with pi over 12 minus a 12th sine of pi. So, simplifying this, well, sine of 2 pi gives me an answer of 0. Okay, So that means this whole thing is going to disappear. Sine pi gives me an answer of 0. So again, this bit's going to disappear. So all I'm left with is pi over 6 minus pi over 12. I get my final answer of pi over 12. Same idea if they put in some definite integration as well. It's just making sure we follow through the last couple of steps, use our square brackets, substitute in, and finish it off. Nothing massively difficult, nothing massively new. All you are now doing is combining your knowledge from our trig identities, as well as our integrating standard functions and our manipulation skills. Can you have a look back onto show my homework now for me and attempt the questions that I ask you to do?